can see that we're currently subscribed to a local service. To connect to another service, we can select that service either as a network node name, or we can enter in an IP address, or here I'm going to enter in a registered domain name and use the internet for my communications. I'm going to use the internet service opcsystemserver.com, where there's an OPC system service running in Texas. So anywhere in the world we will be able to view the alarms from this service. So if we select that service and then click on Add Node, we see this is now an additional network node subscribed for the alarm window. If we click OK, now let's run the application to see what that looks like. This is Windows Vista telling us that this is the first time this application is run here and we need to unblock it. However, you see that we're using TCP communications with .NET remoting and have already obtained the alarms from both the local and the remote service. So we see a number of alarms, but we can't yet tell where the alarms are coming from because we're looking at both local and remote. So during runtime, we might want to modify the alarm columns and specify to include the alarm network node. So if we go down to the network node visible property and set that to true, then we see the network node property available here. So we can see these alarms are coming from opcsystemserver.com, where the other alarms are coming from the local host. So I can acknowledge this alarm, and across the internet we have now sent the alarm acknowledgement to the system in Texas and received the indication back as the alarm being yellow. And we've reviewed the other properties like the alarm rows, alarm toolbar previously, so it is exactly the same component that we looked at in the OPC Systems HMI application. Let's take a closer look at the filtering. That is found under the property alarm filter. Let's take a look at how we might filter alarms based upon alarm groups. We'll use the local service to obtain what alarm groups are currently defined. And now let's include only alarms with the alarm group values. If we select Add Group, we then add that alarm group to the list. And now we will see in this alarm window only alarms that have the alarm group values. We click OK. Now to see what that looks like, let's go into runtime. So now in the alarm window, we only have alarms that have the alarm group values defined for it. Of course, we can change that during runtime as well. If you would like your runtime changes to be retentive, you can use the property called configuration file. This you can then use to specify a file name to store the properties, and this way each operator system can maintain his own configuration files. We have OEMs that create their own SCADA products and use this feature quite extensively to store alarm window configurations and just have one alarm window on one form, but yet be able to subscribe to multiple services and to sort and prioritize alarms in any form they would like. Let's take a look at where the alarm definitions are made. The easiest way to do that is to use the configure application found under the group opcsystems.net. If we go to configure OPC systems, we then go to configure tags. Let's select and define the local service. However, note that you could define a remote service to configure as well. Let's take a look at the tag ramp under the demo configuration. Here we have this tag has a data source as an OPC item with a 1-second update rate. OPCsystems.net does maintain resolution down to 100 nanoseconds for data logging. The display format for the alarm window is to 1 millisecond. That is the resolution that you can have for your alarming. Under the high property is where we define the alarm limit for the high condition for this signal. You can see that we can enable or disable the alarm. When the alarm is enabled, we have a checkbox under the high group. We can also specify the alarm group. We just looked at this where we wanted to filter just based upon alarm groups that only had the name values. Here's a list of existing alarm groups currently defined in the tag configuration. If you want to add a new alarm group, you simply enter it. Let's call a new alarm group called test. Click apply changes. And now in all other tags, when we select a different tag and use the alarm group selection, we now see the alarm group test. The alarm limit itself can be a fixed value as we have here by default, or it can be coming from another data source. It might even be a calculation. We can also specify a deadband. A deadband is the amount in engineering units that the value must come back within in order for the alarm to go out of alarm condition. We have the alarm priority. This is a great property to use to filter alarms. The alarm priority can range from 0 to 2 trillion, and it is up to you to determine whether a lower priority or a higher priority number has the largest severity. We have the time delay property used to delay the posting of the alarm to make sure that the alarm is in the condition for a specified amount of time before reporting it as an actual alarm. We also have the alarm text property. This is the description that appears in the alarm window and is also logged with the alarm logging and is reported in the alarm notification when we're sending out an email. We also have engineering units that can go with the alarm window. We can also automatically set the alarm text based upon another OPCsystems.net tag, which could be from an OPC item, a calculation, or a data source, or even a remote OPCsystems.net tag coming from a remote service. Under the alarm properties, we can also enable time on and counts to keep track of how long the alarm has been in its condition, how many times in a day or in a specific period the alarm has occurred. We can also log the alarm as an event. This is used with the alarm logging and the alarm window to post only one event when the condition occurs. It doesn't require an acknowledgement and it doesn't have a cleared state. We also have digital alarms, and with the digital alarm you either alarm on a true condition or a false condition. With the tag configuration, you can export your tags using the CSV export, and then you can manage all of your alarm configurations using Microsoft Excel, and then use the CSV import feature. You can also change alarm limits during runtime with the OPC Controls.net product or the OPC Web Controls.net product. We will have the high, low, and digital alarm limits. Also, their alarm status is available, whether they're in alarm or not. This way you can turn a button green or red based upon an alarm state. Also, you can programmatically set up tags as demonstrated in the VB.net example. The OPC Systems component is a programmatic interface that is used to define tags, data logging, alarm logging configurations, Anything that is in the OPC Systems service as a configuration can be modified programmatically using the OPC Systems component. That is best demonstrated under Configure CSV Import and Export. That is the easiest way to set up multiple tags. Here we can see we can return the header string for the tag export, and the tag CSV export is a method you can call to return all of the tags with all of the alarm limits and their current values. You can also use the tag CSV import to set tags or even add tags to the configuration. Once you have modified your tag configuration using the OPC Systems Configure application, you would then want to save those changes to a binary file. Here we have the file name demo tags. And then under Configure Options is where we would specify to preload that tag configuration. Here under the property tag configuration is where we would specify what binary file to load when the service starts. And this does run as a Windows service. Now let's see how to log alarms to a database. If we select Configure, Alarm Logging, select the local service, let's enter an alarm logging group name of test. We'll make the alarm logging active, but note you could set the alarm logging active based upon an opcsystems.net tag. This way you can turn on and off alarm logging based upon a calculation or an OPC item coming from a PLC. We have the property to delete data if it's older than a certain amount of time. Under the Filter tab is where we specify what types of alarms to log. Again, with the alarm groups, with nothing specified, all alarm groups are included. If we add alarm groups, we may only want to log alarms with the alarm group values. If we click OK, under the Nodes tab is what services we want to subscribe to. We're going to subscribe from the local service, but we could also log alarms from the remote service as well. And when we implement remote logging, buffering will occur if we lose the network connection temporarily, that the alarms will be buffered on the data source. And when the network connection is reestablished, all alarms will be brought across for the alarm logging. Under the Database tab is where we specify what database engine to log to. We can enable that. We're going to log to SQL Server. The server name that we're going to log to is easy to obtain from the Microsoft SQL Server Management Studio. So if we go to Microsoft SQL Server 2005, select SQL Server Management Studio. I'm using the free-to-use Express version. There is the server name that appears right there. So now let's copy and paste that server name from the SQL Server Management Studio into the server name field. The database, let's call it OPC Alarms. And the table name, we'll call it Test. We can also use SQL Server Authentication or Windows Authentication is the default. Now when we add that alarm logging group to the configuration, we see that appear in the middle column. We are then ready to save that alarm logging configuration so that when we restart the service, we can use Configure Options to specify to automatically load that alarm configuration when the Windows service restarts. Let's take a look at what the table format is now under the SQL Server Management Studio. If we double-click on the Databases object, there we see a new database called OPC Alarms. The database was automatically created by the OPC System Service. If we double-click on that database, we have a Tables object. We can double-click on the tables, and there we have the test table that was automatically created. If we right-click on that table and select Script Table As, select to New Query Editor. That brings up a SQL select statement that we can use to then execute to see the alarms in the table. There we can see the alarm ID, the alarm type, the alarm group, the priority. This is then used with the history feature that's of the alarm window.